Solving for the rate. Example 1. An investment of $20,000 grew by 2631.28 in 1 year. Determine the interest rate compounded semi-annually that was earned. Let's see what we can put on our time diagram. We have an investment of $20,000, so that represents the present value of $20,000. We also know that the time period is 1 year, so in 1 year's time, we know that that $20,000 grew by $2,631.28. That's the interest. So the interest on our investment is $26.31.28. Now, common sense tells us that the maturity value is the interest added on top of the principal. In other words, the final sum is equal to $22,631.28. That's an important piece of information. We also know that we need to determine the interest rate compounded semi-annually that was earned over this time period. This time period happens to be 1 year, and if the interest is compounded semi-annually, then that tells us also that the number of interest periods is 2 semi-annual periods. Why do I need to know that there are 2 semi-annual periods? Because the compound interest formula says that the maturity value S is equal to the principal multiplied by the compound interest factor for the number of interest periods. So now I can substitute, and I have in my formula $22,631.28 is equal to the principal of $20,000 inflated at 1 plus the interest rate per 6 months for 2 semi-annual periods. And now we have to solve this equation. In solving this equation for the variable I, which is contained inside the parentheses, we'll start by dividing both sides of this equation by 20,000. So we'll divide the right side by 20,000 and divide the left side of the equation by 20,000. This will give us a new equation that says 1 plus I raised to the exponent 2 is equal to 22,000 divided by the 20,000, which amounts to a number of 1.13156, and so on. Leave that number on your calculator display. Do not touch the clear button at all. Now what we need to do is to eliminate that exponent of 2 so that we can get access to the variable I inside the parentheses. How do we eliminate that exponent of 2? Well, we raise both sides to the reciprocal exponent. So we'll raise both sides to the power of 1/2. In other words, take the square root of both sides. So we've got 1 plus I to the exponent 1 is equal to 1.135, whatever is on your calculator display, raised to the power of 1/2. And when you work that out on your calculator display, you will end up with a value of 1.06375. And that's equal to 1 plus I. So now I have to solve for I. We've got a very simple equation to solve here. All we have to do is subtract 1 from our calculator display. So we're going to subtract 1 from both sides of the equation, and we'll end up with a new equation that says I is equal to 0.06375. And remembering that the interest rate that we use in our compound interest formula is the interest rate per period. So how is this calculated? This is the interest rate per, if it's calculated semi-annually, it's per 6 months. So now I know that the interest rate is 6.375% per 6 months. What is the nominal rate compounded semi-annually? The nominal rate compounded semi-annually is going to be equal to 2 times that. And 2 times 6.375% per 6 months is equal to 12.75%. So we were looking at 12.75% or 12.75% compounded semi-annually. So the nominal interest rate is 12.75% compounded semi-annually, and this will give us that amount of interest over the 1 year time period. Example 2. A $3,500 investment in stock was sold for $14,000 after 15 years. Determine the average rate of return compounded monthly that was earned on this particular investment. Let's see what we can transfer to our time diagram. Let's start off with the $3,500 investment in stock. It was made today, so let's see, $3,500, that's the present value. We also know that after 15 years, we turned around and we sold that stock for $14,000, so the maturity value is $14,000. So from a principal of $3,500, we've turned it into a maturity value of $14,000 after 15 years. And we want to determine the average rate of return compounded monthly that was earned over this time period. Well, I think what I'm going to do is I'm going to make this my focal date. 15 years is going to be my focal date, and I need to determine the number of interest periods over that time period of 15 years. If the interest is compounded monthly, then there must be 15 times 12 months per year. We've got a total of n is equal to 180 monthly periods. Our compound interest formula states that S, the maturity value, is equal to the principal multiplied by the compound interest factor 1 plus I to the exponent n. And we've got a maturity value of $14,000, and that's equal to $3,500 multiplied by the compound growth factor of 1 plus the interest rate per month for 180 months. Now we have to solve this equation for I. Now you'll notice that I is in parentheses. The $3,500 factor here needs to be eliminated, so we'll divide both sides by $3,500. So we'll end up with a value or a new equation that states that 1 plus I to the exponent 180 is equal to $14,000 divided by 3,500. This is exactly a value of 4, so 4 is equal to 1 plus I to the power of 180. Where does the 4 come from? The 4 comes from the fact that $3,500 multiplied by 4 is equal to the maturity value of $14,000. That maturity value is 4 times the original principal. That's what S divided by P tells us. 4 times the original principal. Now I still have to solve for the interest rate I, so I'm going to eliminate that exponent of 180, and I'm going to do that by raising both sides to the reciprocal exponent or reciprocal power. So we've got raised both sides to the power of 1 over 180. So 1 over 180, and you have to be very careful when you work this out on our calculator. So we'll end up with 1 plus I to the power of 1 is equal to 4 raised to the exponent 1 by 180. This is going to work out to a value of 1.00773, etc. I'm going to put little dots here. I don't want you to clear your calculator. Leave the entire value on your calculator display. You're going to need to subtract 1 from both sides of the equation to solve for I. So we'll end up with a new value of I is equal to 0.007731, etc. Now this is the interest rate per, let me see now, it's per month. So if this is the interest rate per month, which is a little bit less than 1% per month, 0.773% per month, what you're going to do to determine the nominal rate compounded monthly is you're going to multiply this number that's on your calculator display by 12. So you will end up with a nominal rate of 9.277 68% compounded monthly. Well, I'm going to round that off to 2 decimal places, or I will say it's approximately 9.28% compounded monthly. So a nominal rate of 9.28% compounded monthly is what this investment earned.